I think this is also a review for the people who are in my calculus 1 class. The fundamental theorem of calculus says what? If you integrate a function a to b, f of x dx, and if f is smooth, what is this equal to? Huh? Big F of x. In other words, evaluated as b minus the big F evaluated as a. Huh? Where what?
Big F.
Where big F is the antiderivative of little f.
Yes.
Where the derivative of big F is little f. This is the fundamental theorem of calculus. Yes. What is another way to think about it?
After enough time.
What if you put a derivative here?
Just use lowercase steps.
Indeed. We've got the derivative of this function is that function. That's another way to do it. So you need the antiderivative of this function. The function that's differentiated to f differentiates to that function. So sometimes you write like this. E to a q prime of x dx is q of b minus q of a. So if you want to know what is the change in a function q over an interval b to a, integrate the derivative of q from b to a. That will tell you how q changed over the interval b to a. It was called change. Of course, sometimes you want to be told that q prime is the derivative of q. You are expected to know that, especially if you're taking physics. You're expected to know that the derivative of position is velocity. So that if you are putting the velocity here, you're getting the change in position here. What we were saying is, if you integrate the derivative of a function, if you integrate the velocity, if you integrate the derivative of the position, you should get the change in the position. So that is saying quite a lot. It may look like it's not saying anything. Especially if you're talking physics, biology, chemistry, finance. Saying if you are using velocity and position. Because position differentiates to velocity. That's why I actually prefer this. Then I know I'm looking for antiderivatives. And I know that the derivative of position is velocity, and the derivative of velocity is acceleration. So if I integrate acceleration, I must get velocity. And if I integrate velocity, I must get position. That is the real meaning of the fundamental theorem of calculus. So, S of lots and lots of ways of saying this. Probably the best way. A particular example of that would be this. An even more specialized example of that would be this. But if you started at 0, then this would be your position function. Function. So this is your velocity. And you know your initial position. Then you can find your position function. You can find your position function. So, now you know that ds by dt is v of t. And dv by dt is a of t. So that if you integrate a of t, a of t, you will get v of t. So let me do that. If I integrate the acceleration, if I integrate the acceleration from 0 to x, the acceleration being a function of time given to you, then you say, oh, you are integrating the velocity, the derivative of the velocity. You are integrating the derivative of the velocity, then you must get the velocity. If you're integrating the derivative of the velocity, then you must get the velocity. Function. If you integrate the derivative of the velocity, you must get the velocity. And if you integrate the velocity, if you integrate the derivative of the position, if you integrate the derivative of the position, then you must get the position. But there are these constants floating about here. We can do nothing about them. Why? Because the laws of physics are the laws of physics. There are two things with the same acceleration. When you try to give the velocity, you integrate that, and once you get that, you will have the velocity. But once you have the velocity, you will have to integrate that to get the position, and you know they have different positions. It will depend on the initial position. The position function. We have two things moving at the same velocity. The velocity of my particle is 10 meters per second. That is my law. I'm not giving the position. You say that if the velocity is 10 meters per second, then you want to know where I am 5 seconds in, the position function. You see, if I take the 5 multiplied by 10, 50 from where you started. If you start at the origin, good for you. Let's do some problems. So here's a problem. This is from the practice problem. Now when I put up. Determine y where the derivative of y is 3 over 6 plus x squared. Y being a function of x. Oh, we know there are many things that will have that derivative because of that constant. So you will need to tell me which one is corresponding to you. Where did you start? So we know that y of x minus y of 0 is equal to what? The integral of the derivative of y from 0 to 6. Everyone with me? The integral of the derivative of y from 0 to 6. That is the fundamental theorem of calculus. And what is the derivative of y? It's a function that you will have to find the antiderivative of. What is it?